All right, let's dive into section 5.6, which is about rational functions. Rational functions are basically functions that are fractions, that have like a numerator and a denominator. It's a little more specific than that, but that's where the word rational comes from. Rational comes from the word ratio, which deals with, means fraction. Same way we have rational numbers, which are fractions as well. So we're going to look at this type of function in this section. And study it from a few different perspectives. One of the things we're going to be looking at is something called asymptotes. And when you're talking about asymptotes, it is useful to talk about, instead of values of x, talk about like where x is going. So instead of saying x is equal to 5, talk about x approaching 5. Or instead of talking about like x being a really big number, you could talk about x approaching infinity, like getting bigger and bigger. And when x is approaching things, we don't use equals, we use an arrow notation. Now, I've already actually used an arrow notation once in a previous video about end behavior of polynomials, so I apologize for not explaining what it is, but let's do it now. So if you see this notation x arrow a, where a is like some constant, like maybe x arrow 2 or x arrow -5 or whatever, that means, I'm going to make a little table here, that means x approaches a, okay? And so that might be like talking about x getting close to 2, like 2.01 or maybe 1.99, like numbers very, very close to 2. If you see it, the same notation, but with a little minus up above it, it means x approaches, and I'm going to abbreviate approaches with APP. Okay, just so I don't have to write approaches every time. Let's see, this means x approaches a from the left. So that little negative superscript after the a means from the left. Likewise, you can probably guess, if you put a little superscript plus, that means x is approaching a from the right. Okay, so that little negative and positive doesn't actually mean negative and positive. It means just to the left and to the right. So like you could subtract a little bit or add a little bit. And so that's what that means. We have a similar, okay, so that's approaching from the left or the right. A, if it says x approaches a, that kind of means like from both sides. So consider both sides. We also are going to want to talk about approaching infinity and negative infinity. I've mentioned before that infinity and negative infinity are not numbers, but rather like directions. Like, on the x-axis, infinity is off to the right and negative infinity is off to the left. So with this notation, we can talk about going, like what happens as x gets bigger and bigger and bigger, or what happens as it gets smaller and smaller and smaller. So we're going to be able to use this to talk about end behavior, like we did for polynomials. So, okay, now we're going to look at an example, and we're going to use this arrow notation to talk about what are called asymptotes. This is one of the simplest possible rational functions you could possibly have is just the function f of x equals 1 over x. This is one of the functions that was in that toolkit that we went over a little bit earlier back in like chapter 3. So this is sometimes called the reciprocal function because what it does is it just takes inputs and reciprocates them. So we're going to start looking at a few different situations. The first situation we're going to look at is what happens as x approaches 0 from the left. Well, as x approaches 0 from the left, we're going to make a little table to discover what happens here. We're using this example. This is our f of x for all of this here. So as x approaches 0 from the left, that would be like numbers very close to 0. Let's pick a number close to 0, but on the left side, like negative 0.1. That's negative 1/10. If you stick that function as our x input into this f, then 1 divided by negative 1/10, this is just going to reciprocate that fraction. And so instead of 1/10, we're going to get 10, but it's still negative 10. If you stick in negative 0.01, that is negative 1/100th. Reciprocating the fraction will give you negative 100. Negative 0.001 is going to give us negative 1,000, and so on. And what's happening is as this set of numbers is getting closer and closer to 0, These numbers are getting closer and closer to negative infinity. So as x approaches 0 from the left side, f of x is approaching negative infinity, like that. Okay, so let's see, we're going to build a graph over here. So as x is approaching 0 from the left, okay, so as x gets close to 0 from the left side, that would be like coming in sort of right here, all right? Then our function is actually going down like this towards negative infinity. And it gets smaller and smaller and smaller and smaller going down. So this is behavior number 1 right here. This area over here is going down. 2. What happens as x approaches 0 from the right? Well, we can make another table, and this is going to look really similar. Let's take similar numbers except positive this time. 0.1 will give us 10, 0.01 will give us 100, 0.001 will give us 1,000. So we're talking about as we approach 0 again with these numbers, but from the right-hand side, this time our f of x values are approaching positive infinity. So on the graph, that means as we get close to 0 from the right, we're going up. Okay, so we have approaching negative infinity on the left and approaching positive infinity on the right. So this is behavior number 2 right here. Next, now let's look at what happens as x approaches infinity or negative infinity. So this is going to be end behavior. First of all, as x approaches negative infinity, we can kind of take these numbers and swap them around now. Let's have x be like negative 10. Then f of x, my output, is going to be the reciprocal of that, right? 1 divided by negative 10, which is negative 1/10, or negative 0.1, right? So if I go out to the left here to 10, I'm going to be at negative 1/10, just beneath the x-axis. If I go all the way out to negative 100, now I'm at negative 1/100th, right? Negative 1,000 on the x-axis is going to give me negative 1/1000th, and so on. So as x is approaching negative infinity, my f of x approaches 0, but from the left, right? Or sorry, from the left, in this case, because we're talking outputs, which are y coordinates, it's actually like not so much from the left as it is from beneath. So as our x values go out towards negative infinity in that direction, my graph is going to come up and approach 0, but from below, right? Like that. And so that right there is behavior number 3. And then you can guess number 4. Oh, I forgot to write in what's going on here. For x approaching 0 from the right, it was approaching positive infinity. As x approaches negative infinity, f of x approaches 0 from below, so from the negative side. And then finally, as x approaches positive infinity, you can guess I won't bother writing it in, but we're going to get f of x approaching 0 again, but this time from the right, or from the positive side. So this is going to come down like this, and that right there is behavior 4. So this is the graph. This is the graph of y equals 1 over x. And actually, if you want to stick in some values here, 1 over 1 is equal to 1. So it has a point right here at 1, 1. And 1 over negative 1 is equal to negative 1. So it has a point right here at negative 1, negative 1. And then there's other points on this graph that might be familiar, like when x equals 2 over here, for example, this point is going to be at 2 comma 1/2. And when x is equal to 1/2, you'll have a point up here at 1/2 comma 2, and so on. So that's what this graph looks like. This is actually a hyperbola. We've already studied hyperbolas, and this is a hyperbola which is centered at the origin, and it has this transverse axis that runs diagonally, like that. So this graph of this function has 2 what are called asymptotes. So one of the asymptotes is this line. An asymptote in general is a line or curve. Usually you just talk about linear asymptotes, but technically you can have curved asymptotes. They're not part of the graph, right? So the points on this asymptote that I've this dotted red line here, those are not points on the graph, like they don't represent solutions. But it's a line that the graph gets closer and closer and closer to when you go somewhere, when it approaches something. So in this case, as x approaches 0 from the left or the right, we are approaching this asymptote. And the asymptote here, this is what's called a vertical asymptote. And we describe the asymptote with the equation that would describe that line. So a vertical line equation is x equals a constant. In this case, it's occurring right here as x is approaching 0 from the left or the right. So x equals 0 is the equation of that vertical asymptote. Now there's also a horizontal asymptote, because the end behavior of this function is that x is approaching 0 on the left and on the right. Yeah, so that has another line here at y equals 0, and that one is a horizontal asymptote. So there we go.